Today we're going to look at another way to do long division if you're dividing by a linear factor. The remainder theorem states if a polynomial f of x is divided by x minus k, so this is my divisor, what makes your divisor 0 in this case would be x equals k. So dividing it by x minus k gives you a remainder. You can also get that remainder by plugging in k, which is 3 in this case, into this polynomial. So if I plug in 3, I'll have 2, and then 3 to the third, minus 11 times 3 squared, plus 3 times 3, then plus 36. And that gives me a remainder of 0. If I do long division on that exact same problem, that is my remainder. So I can see if something is divisible very quickly by just looking at the remainder. If the remainder is 0, it goes in evenly. Let's go ahead and divide this with long division. So my divisor was x minus 3. My dividend was 2x to the third minus 11x squared plus 3x plus 36. I have 2 terms on the outside, so I start above the second term. Notice this one didn't need a placeholder on my dividend or divisor. I need to get rid of the term on the left inside here, the dividend. So x times what gives you 2x to the third? That's going to be 2x squared. And then multiply 2x squared with both of those terms. So I'll have 2x cubed minus 6x squared. And then I subtract, so that will give me 0. Negative 11 minus a negative becomes plus 6. So that will give me negative 5x squared. Drop down your 3x. X goes into negative 5x squared. Negative 5x times. So I'll multiply negative 5x with both of those terms. So that's going to be negative 5x. Negative 5x times negative 3 is plus 15x. And then I subtract. That'll be 0 when I subtract that because I'll be subtracting a negative, so that makes it a plus. And then 3 minus 15, that gives me negative 12x. Drop down your 36. X goes into negative 12x, negative 12 times. Multiply through, and you'll get negative 12x plus 36. And when I subtract, that becomes a plus. That'll become a minus here. So those both will give me 0 for my remainder. So notice the 0 here is also the same remainder I got up there. If I just plug the 3 in, I don't get the quotient piece. And sometimes we might want that quotient piece. Another way to do long division when you have a linear factor is called synthetic division. And we're going to do that now. Our first step on synthetic division is to write the coefficient of the dividend. So we're going to write all the coefficients here. So I've got 2, negative 11, 3, and 36. If you have a placeholder, you need to include it. I have every place covered here, so I didn't need a 0 in here for my dividend. And then what makes your divisor 0 is what you're going to put in this box. And that is in step 1 as well. So I'm going to put a 3 here. And then you're going to drop the coefficient or copy the first coefficient in the dividend below the horizontal bar. So that's all step 1. And now we're going to multiply the first coefficient by the divisor and write the product under the next coefficient. So we're going to multiply those, which is 6, and then we add. And we continue to repeat that until we get to the end. So 3 times negative 5 is negative 15. And then we add. 3 times negative 12 is negative 36. And then we add. This is the same problem that we did above. When you divide this, you're dividing by a linear factor, so this is going to drop down a power. So it's now going to be x squared here. So this is 2x squared minus 5x minus 12. And then my remainder is 0. This is my remainder here. Notice I get the same quotient here that I did with the long division. So if you scoot your paper up, that's the same answer that I got for my quotient. But instead of having to do long division, synthetic division is nice. Remember, on long division, you're subtracting. On synthetic division, you are adding. Let's do a couple more examples. I'm going to write my coefficients down. I don't need any placeholders. So 3, 9, negative 2. Draw my horizontal bar. What makes my divisor 0 is 3. Drop your first term. And then you multiply and add. Multiply. So 3 times 18 is 54. And then I add those, which gives me 52. This was x squared. This will now drop 1 degree. So this is 3x plus 18. And then my remainder is 52. And I can put that over my divisor of x minus 3. So if you do long division, you'll get the same answer as I did with the synthetic division. Let's try the next example. And then on this one, notice I go x to the 4th, x to the 3rd. I don't have an x squared term, so I'm going to need to put a placeholder there. And then 5x and minus 1. So I need a placeholder for 0x between those two. So 3, negative 1, 0, 5, negative 1. What makes the divisor 0 is negative 2. That's what goes in the box. Drop your first term. Multiply, so that's negative 6. And then add, that's negative 7. Negative 2 times negative 7 is positive 14. And then I'm going to add. Then multiply those together. So negative 2 times 14 is negative 28. And then add, you'll get negative 23. Multiply 2 times negative 23, that gives you positive 46. And add, that gives you 45. This will drop down 1 degree. So that will be 3x to the 3rd minus 7x squared plus 14x minus 23. Plus, then I have a remainder of 45 over my divisor, which was x plus 2. It's necessary to write them in standard form, so you have correct term above each place. So always have them standard form, highest exponent to lowest exponent. If you don't have a term, if you skipped a place, you have to put a placeholder. And that could be on the divisor or the dividend. And then how do you recognize the quotient and remainder? You're going to drop down 1 degree when you divide by a linear term. And your remainder is the last term in synthetic division. go ahead and pause this video and see if you can do the next two examples. Hopefully you paused it. On this one, the divisor, x plus 2, what makes that 0 is negative 2, so that's what goes in the box. I have 3, 2, 1, no x's, so all my places are covered. So 1, negative 1, 4, negative 10, write your coefficients down. Your first term drops down, and then multiply and add. Negative 2 times negative 3 is positive 6, and then I'm going to add. Negative 2 times 10 is negative 20, and then I add. Dividing this out then, it drops down 1 degree, so that's my coefficient for my x squared term. Then minus 3x plus 10. My last term is my remainder, so that's going to be plus negative 30 over x plus 2. On number 2, my divisor, what makes that 0, is negative 3. Write down my coefficients. So I have 3x squared, 3x cubed, 17x squared, 21x, and minus 11. I don't skip any places, so I don't need a placeholder on that one. Drop your 3 down, and then I'm going to multiply and add. Negative 3 times 8 is negative 24. Then I'm going to add. Negative 3 times negative 3 is 9. And then I'm going to add. It drops down 1 degree, so it was x to the third. This is now going to be 3x squared. And it just goes down 1 degree each time. So plus 8x minus 3. And the last term is my remainder, so negative 2 over x plus 3. Synthetic division works with linear factors, so you want to make sure that you don't have anything above an x to the first here. The factor theorem, if you have a polynomial that has a factor x minus k, that would mean what makes that 0 is x equal k. So if I have a remainder of 0, that means that k is a 0 or solution, x-intercept root, and x minus k is a factor. So if I give you that x equals 2 is a 0, that would have meant that x plus 2 is a factor. I'm going to go ahead and put what makes my factor 0 in the box. I don't need a placeholder here. I'm going to write my coefficients. So 1, 2, negative 9, negative 18. Drop your 1, your first term, and then you're going to multiply. Negative 2 times 1 is negative 2, and add. Then multiply those. So negative 2 times 0 is 0, then add. That'll be negative 9. Then multiply and add. And notice my remainder is 0. And this drops down 1 degree, so this is x squared plus 0x, so I'm not going to put that in there, minus 9. My remainder was 0. And if I wanted to factor this, I could continue factoring this. So this would factor, that's the difference of 2 squares, into x plus 3 and x minus 3. So f of x, this polynomial up here, has 3 factors. The first factor was x plus 2. The next factor was x plus 3. And the last factor was x minus 3. So if I wanted to determine what my zeros are, your zeros are when f of x, your y value, equals 0. And that happens when any of these factors are 0. So my zeros would be negative 2, negative 3, and positive 3. It has 3 zeros. Let's do the same thing for the next problem. So if x equals -2, that means my factor was x plus 2. But what goes in the box is what makes this factor, my divisor, 0, and that was -2. And I'm going to look, do I need a placeholder? 3, 2, 1, no x's, so I don't need a placeholder. My coefficients of my dividend are 1, 8, 5, and -14. Draw your horizontal bar, drop your first term, multiply, -2 times 1 is -2, and add, gives me 6. -2 times 6 is -12, and add, it's -7. -2 times -7 is 14, and add, and I get 0. This drops 1 degree. It was x cubed, now it's x squared. So x squared plus 6x minus 7. And that remainder is 0. I'm going to go ahead and factor this. So what multiplies to -7 and adds to 6? I'm unfoiling this. And so that would be 7 and -1. So this factors into x plus 7, x minus 1. So my full factorization for f of x, my first factor was x plus 2. And then my other factors were x plus 7 and x minus 1. If I set f of x equal to 0, I could find my zeros for my function. So my zeros, what makes each of those factors 0 is -2, -7, and 1. So when you have higher order polynomials, you can factor them if you can find some zeros. And we're going to go in the next few lessons on how to find some zeros.